Well, in the previous video, I said in this video, we're going to be talking about formulas and names of ionic compounds, and that is true, but there's something that I missed. This is a table that's found in your textbook and also is here in the slides that you can use for a lot of these names of different cations, okay? These are typical cations that we're going to encounter in this class. So this is a table you can have as a reference when we're naming compounds on a quiz or an exam, okay? So that's officially ending the last video or the last section. So now let's move on to formulas of ionic compounds. So here's some guys that are known as polyatomic ions. And so polyatomic means they're ions formed by multiple atoms bonding together. And these guys over here are the ones you're going to need to memorize, okay? And their names are found in this table. Okay, so these are the guys, again, on the right that we're mainly going to be focused on. But this table, similar to the last table I showed you, this gives you an exhaustive list of pretty much any polyatomic ion we're going to be encountering in this class. And this list is actually going to be useful later when we're naming acids, okay? So just have this list in front of you. These guys are mostly anions. I think actually in this list, they are all anions, except this guy snuck in here. This is an ammonium ion, okay? And he's found on this chart right here, okay? He's an ammonium ion, polyatomic cation. So he snuck onto the last list, but again, these are mostly or all anions in this case, okay, with either a 1-, a 2-, or a 3- charge. So again, we can use this list as we go forward in naming these compounds. And so an ionic compound, we've already talked about this a little bit, is a chemical compound composed of ions held together by electrostatic forces called ionic bonds. And we talked about how in ionic bonding, there's a stealing of electrons, like with sodium chloride here. The sodium gives an electron, the chlorine takes an electron, becomes a chloride ion. So that was in a previous section we talked about in chemical bonding. And the formula unit must have an equal number of positive and negative charges. So, and we'll see that the net charge of these compounds that we're forming has to be neutral, has to be 0. Okay, so we need the correct amount of cations and anions to balance out the charge or to make sure that the compound that we're forming is neutral. And if that doesn't make any sense, it will in a second, I think. So how do we write the formula of ionic compounds? Well, we first write the formula of the cation followed by the formula of the anion. It's pretty easy. So we insert subscripts to show that the number of each ion that's needed in the formula unit to make the sum of the charges equal to 0 with the fewest number of ions possible. So if you only need one ion, the subscript isn't shown. And if a polyatomic ion is needed, and you need more than one of those, you enclose the formula of the polyatomic ion in parentheses and place the subscript after the parentheses. So this is a list that you can have in front of you, and you can even just pause the video, take a screenshot, or write it down real quick. So when we're naming compounds in a second, or writing their formulas, I should say, you can have this reference and have that chart in front of you too. Find it in your textbook, or, you know, like I said, take a screenshot and have it somewhere else so you can follow along. Okay, so let's write the formulas of these ionic compounds. So we have plenty of examples here. So the first one is magnesium chloride. And what we're going to do here is, my wife has just brought me a snack. So what we're going to do here is write the formula of magnesium chloride. So what you do, now I want that snack. Okay, is first I suggest writing the formula of the ions. Okay, so magnesium, this is not a transition element. So we looked at how to get its charge in a previous video as a 2+ charge. chloride here, okay, the chloride ion has a -1 charge. And I'm going to include the 1 there, even though we don't need to most of the time. So here's what we do. Remember, this needs to balance out the charges of the final compound that we put together, or the final formula. So what you're going to do, imagine that we're going to do something called crisscrossing the charges. What do I mean by that? The 2 that's up here, we're going to bring it down to here. And the 1 that's here, we're going to bring it down to here. Don't worry about the positive or negative signs. Just take the number. So the formula is going to be this. Okay. And remember that 1 is omitted. Okay. That was one of our rules. And you can go back and say that rule. Okay. And does this make sense? Well, let's see. Magnesium is a 2+ charge. Okay. And chlorine is a -1 charge, but I have 2 of them here. So the net charge is 0. So it's balanced, okay? And that's one of our requirements for these compounds, okay? So let's do the next example. Aluminum, okay, is a 3+. Again, we're just finding these like we learned in the other videos on polyatomic ions or monoatomic ions. And this is oxygen. And again, what we're going to do, we're going to bring the 3 down, bring the 2 down. And what we get is aluminum, 2 of those, and 3 oxygens. And again, that makes sense. I have 2 +3 charges and 3 -2 charges. So the net is 0 again, the net charge of the molecule. Okay, so I'll do one example and then I'll have you pause the video and do the remaining 3 here. We have barium nitrate. So I'm just writing the formula of the ion down here. So I'm assuming that you're comfortable doing that. If not, please reach out to me and I'm happy to help. So barium is a 2+ charge. Nitrate, this is one of our polyatomic anions. It's on that chart. It's one of the ones that I said to remember. Okay, so this is barium nitrate. So what we do here, again, bring the 1 down and the 2 down. But remember, one of our rules is when you have a polyatomic ion, all of this goes in parentheses, okay? So the 2 is going to go on the outside of those parentheses. Okay, so barium, NO3, that's the polyatomic anion in parentheses, and the 2 goes on the outside. Okay, and I'll have you check to see if the charges are balanced there and net neutral. All right, so when you pause the video, do these 3 remaining examples, and then I'll put down the answers, and we'll see if we got the right answer. Okay, so moving a little bit faster now, we have, let me go back to red here so it matches. We have calcium, 2+, hydroxide. Okay, so again, we cross the charges. I'll skip that step for now. OH2. Okay, that's calcium hydroxide. All right, potassium nitrate. Potassium, that's what nitrate looks like. Across the charges, they're all 1s, so they're all emitted. NO3. Okay, so hopefully you got these guys as well, and your answers are matching mine. Okay, 2+. Phosphate is this guy. This is interesting. So we crisscross. What you should have gotten is barium phosphate. Okay, so again, plenty of examples in your homework. So go and do those. Do the ones in your textbook even to give you even more practice in figuring this out. And always check to see if the formula has a net neutral charge. It'll help you out a lot, okay? So that's it for that section. In the next section, we're going to talk about naming ionic compounds.